All right, section 8.4, surface areas and volumes of similar figures. Now, this is a review of yesterday's lesson. When two figures are similar, the ratio of their perimeters we know is equal to the ratio of their side length. So side length ratio is equal to the perimeter ratio. When the dimensions of a figure are multiplied by k, the perimeter is also multiplied by k. So if I said, just like the last problem we were looking at, if I said that I had a shape that was, I multiplied everything by 4, well, the perimeter is also going to be multiplied by 4. The area, though, when two figures are similar, the ratio of their areas is equal to the square of that side length ratio. So when the dimensions of a figure are multiplied by k, the area is multiplied by k squared. So if I multiplied all the points or all the side lengths by 4, the area is actually going to get multiplied by 16, the square of 4. Now, what do you think the factor is going to be for the surface area? Is that going to be different than the area ratio? Is it going to be the same, greater, less than? What do you guys think? Xander?
K cubed.
For surface area? So this was from yesterday, right? We did perimeter and area. Is area different from surface area? It's not. The only reason we call it surface area is because normally when we do area, we're thinking of a flat shape. Surface area is the area on a three-dimensional shape, but we know that we can make a three-dimensional shape flat. That's called a net. And so because area is just area, when we do surface area, the ratios of their surface areas are going to be the square again, the same as yesterday, the square of their corresponding side length ratios. So if you gave me the radius of A and the radius of B, I can create a ratio, and then I'll just square that, and I'll have the surface area ratio. In the same way that we squared yesterday's ratios to get an area ratio, surface area, same thing, both the area. Okay. Now you're getting onto, when you said k cubed, Xander, you're getting into the volume part, which we'll also get into in this lesson as well. Okay. So when the dimensions of a figure are multiplied by k, the surface area again is multiplied by k squared. So surface area, it's like yesterday we were doing 1 dimension, 2 dimension, and today we're doing 2 dimension and also 3 dimensional. Okay. Hey, what's up, baby? All right. I'll get this back to you later. Who's it go to next?
I'm supposed to take care of it. I want to go ahead and send it now.
Yeah, I'm just recording right now. That's all right. There you go. Thank you. Yep. All right. So two pyramids are similar. What is the surface area of pyramid A? And so they give us the surface area of pyramid B, so we can find the surface area of pyramid A. They also give us the height of each of the pyramids. What is the height of pyramid A? Garrett? What is the height of pyramid B? Garrett? Okay. And Garrett, what would 6 over 10 reduce to?
3 over 5.
That's right. So this is just like what we did yesterday. So now that I know that the side length ratio, corresponding side length ratios, I know the height's not technically a side length, but we're going to think of it like this. If I know the side length ratio is 3/5, the surface area ratio, which is an area ratio, is going to be the square of that. So Emerson, what would the square of 3/5 be? That's right, 9 over 25. Nine over 25 is the ratio we're going to use then. So if the area ratio is 9 over 25, 9, of course, was the number we got from pyramid A, and 25 was the number we were getting from pyramid B. When they give us the surface area of pyramid B down below, that's going to go down below where we were putting all the numbers that went with pyramid B. And so we can put an X right there, and that's going to represent the surface area. So I don't actually need to know the other lengths, the other sides, or anything like that. I don't even care that, you know, how many sides it has. And if I was doing surface area of a pyramid, we actually have a formula for that. Do you guys remember what the formula for the pyramid was? Not 2b, that was for prisms. There's only one base on this one. So S equals B plus 1/2 PL. Do you remember that formula from a while back ago? No? Yeah. So yeah, I don't even need, well, the nice thing is I don't need to know that formula to find the surface area. And I wouldn't actually be able to use that formula to find the surface area because they don't give me the other sides. I don't need the formula because it tells me these two pyramids are similar. And so I can just use a proportion, but I can't use the proportion 3/5, the side length ratio proportion. I have to square it and use the 9/25. And so that's going to give us this new proportion with a surface area of what? 25x equals 5,400. And what do you get when you divide, Lucy?
216.
216. And how do I label surface area, Lucy?
Feet cubed. Or squared.
Squared. Yep, the same way as I do normal area. Yeah, feet squared. And make sure we're labeling our answers on our work papers. It's a bad habit to not label anything on your work paper, and all of a sudden for your quiz, you have to label everything and try to remember that. It's kind of difficult to do. Okay. Do another example together. The two similars are solid. Find the surface area of the red solid. Okay, so I'm looking here at the side length ratios. It looks like the side length ratios from, we'll go, I guess we can go red to blue. We've kind of been doing that throughout this chapter. 5 meters for the smaller prism over 8 meters for the larger prism. If I look at those two corresponding side lengths, what does 5/8 reduce to? Person? It does not. Okay, so I'm ready to go. I've got my side length ratio. I need my area ratio though. So I'm going to take my side length ratio and I'm going to square that side length ratio. And Seth, what will I get when I square 5/8? That's right, 25/64. That's the ratio that I want to use. And so I'll just do that down here. 25/64 is equal to, and then I'm going to place the 608 meters squared because it went with the blue shape down on bottom where the 8 was located, which is now a 64. And so I'm going to put the 608 right there. I'm going to put my X right there. I'm going to cross multiply this. And I'll have the area of this, the surface area of this red prism without knowing any of the other side lengths of this red prism. Shane, what do you get when you multiply 25 times 608?
15,000.
Okay, so we got 64x equals 15,200. Go ahead and divide it. Tell me what you get. 2,000. Okay, 237.5 makes a lot more sense. The reason I was struggling with the answer, at least what I thought you said, is because shouldn't the area of the red prism be smaller than the surface area of the blue prism? I mean, something to keep in mind, right? Yeah, okay. So there we go. Now what I want you guys to do, I'm gonna pause the video for a second. I want you to try example B on your own without me, and then we'll come back, check, see how you did. All right, who thinks they have the correct answer for this one? Okay, Shane, you think you have the correct answer? But you did the last one though. So of course you would have the correct answer because I called on you. Sky, tell me what your side length ratio was. Okay, so you did blue to red. You did not have to do 4/5. You could have used 5/4 as long as everything you did was consistent with the way you set it up. So you did 4/5. And then you squared that ratio. What'd you get? Okay. Okay, so then she uses that ratio. And then where did you put the 110? Ah, okay, that's gonna be wrong. Because remember when you said 4/5, you gave me this number first, then the red number. So you would have to put the blue number back on top and then the red number. Does that make sense? I kind of colored it. So you gave me 4/5, right? 4 was from the blue cylinder, 5 was from the red cylinder. Since the 110 square centimeters is also from the blue, you'd have to put it on top, just like you put this blue 4 on top. Okay, so you should have set it up as 110 on top and then your X down here. Now, if you did 5/4 as your ratio and then got 25/16, then you would have had the 110 on bottom and your X on top. So as long as you reversed it and everything was lined up the way you had it originally, you're going to end up both of you with the same answers. So Sky, after you recalculate this, tell me what 25 times 110 is.
2,700.
Okay, and then divide that by 16. 0.8875. Okay. And what are we labeling this in if it's an area problem? That's right. Okay. Questions on that? Do I have thumbs up? Sky, do it right? All right, good. All right, moving on to volume then. When two solids are similar, the ratios of their volume is equal to the cube of the ratio of their corresponding side lengths. Or basically saying, when you find the side length ratio, raise it to the third power instead of the second power, because now we're in cubic units and not square units. So if I told you that all the dimensions of these two cylinders here were multiplied by K, well, let's say K is 3, for example. Their perimeter would be 3 times larger. Their surface area would be 9 times larger. And their volume would be 9 to the third power. Anyone know what 9 to the third power is? Oh, using your calculator, it's a way out. Way out. Carson? That's no, that's to the fourth power. That's 3 to the fourth power. No, that's 3 to the fifth power, actually. Wait, 729?
Yeah.
No, sorry. Not 9 to the third power. 3 to the third power. So I think you misunderstood me. 3 to the third power, Jimmy. 27. Yeah. Okay. I see why you guys are giving me that now. I was like, wait a second, where did you get that from? Yeah. So if I'm timesing all the points or all the sides by 3, the perimeter is going to increase 3 times larger. This area or surface area is going to be 9 times larger, and then 3 cubed, the volume will be 27 times larger. Okay. So you're raising it to the third power. Okay. So let's try this again. Doing the same thing we just did moments ago, but with a volume ratio instead of a surface area ratio. Start with the side length ratio. Jace, can you give me the side length ratio? And let's just have everybody do the same way. Why don't you give me, we'll go red to blue.
5 to 12.
5 to 12. Okay. So 5 to 12. It's not that you couldn't go 12 to 5. I just want to make sure we're all kind of doing the same thing and not getting 2 different sets of work here. Okay, Jace, is that side length ratio reduced? Yes, it is. So to find the, I'm really struggling with why notability is like glitching out, but I don't know. So I'm going to raise the side length ratio to the third power because they don't give me surface area, they give me the volume of that blue cone. So Jace, you might need to use a calculator here. 5 to the third power and then 12 to the third power. One, that's called 125. Okay. Okay, 1,728. Remember, it's been a little bit since we've cubed a number before. If you have a calculator like this, you have a exponent arrow right there to the third. Some of you, if you have a different calculator, might actually have a cubed button like if you have an X squared button and an X cubed button you could use. Okay, so I know that ratio is not going to reduce. I know that ratio is not going to reduce because we already knew 5/12 is reduced. Okay, so we're not going to have to try to reduce 125 over 1728. Okay, so that's the ratio I want to use. And then now I'm going to finish my proportion. Okay, so I'm going to chop that off right now. This is a separate problem. I just don't have room to write both of them. Okay, so there's my volume ratio. If the blue cone has a volume of 288, where do I have to put 288, top or bottom, Julia? Bottom. I want to finish this problem. I'll pause, restroom break, we'll come back and we'll finish the last two examples that we have here, okay? So 208 goes on bottom, 288, X goes on top, cross multiply.
Darian Tyler, please come to the office.
This is gonna get big. 1,728X equals, let's do one step at a time. Xander, what's 125 times 288?
36,000.
You trying to recite it from memory?
I already plugged it into my calculator.
Oh, well, what did you get? Oh, that's it. You paused. Okay. I thought you paused like you were thinking. Okay, go ahead and divide by 1,728. Maybe I should do it too.
Mr. Max's class, please come to the cafeteria. Sixth period Max.
Okay, go ahead, Xander.
Thank you.
20.83 repeating.
20.83 repeating, and that would be, since it's volume, you want to label it centimeters cubed. All right, we'll do B, and then the last example here, and go ahead and take a 5-minute passing period. Example B. All right, so let's start with the side length ratio for these two perimeters. What is the side length ratio, Emerson, of these two pyramids? I think I said perimeters, pyramids. What's the side length ratio? Okay, so Emerson is deciding, you know what? I'm going to do red to blue again, even though they kind of mixed it up with the red on the other side. I like it. Red ratio to blue ratio would be 4:3. Emerson, is that ratio reduced? It is reduced. Okay. Now, do we need an area or volume ratio here? A volume ratio. So we're going to raise it to what power? That's right. Can you tell me what 4 to the third power and 3 to the third power is?
At this time, we are going to begin our scheduled dinner drill.
Oh, they're doing it early.
Please relocate to the designated area.
Hold that thought.
We'll lead you back to your classrooms over the intercom.
All right, Emerson, 4 cubed is what?
4 cubed is 6.
And 3 cubed is 27. So our volume ratio is 64 to 27. Okay, so now that's what I'm going to use. I'm just going to draw a line because I don't want to say that 60, that's all equal to the same thing, but I do need to set up a proportion. And where do I put my 9 cubic inches? On top or bottom here, Lucy? Yes, because Emerson went red to blue. We have to continue that theme of going red to blue, and we have to put the 9 on bottom. And so remember, I'm expecting this to be a larger volume because I'm finding the volume of the red pyramid. And so I'm ready to cross multiply. 27x is equal to 64 times 9. Seth, can you tell me what 64 times 9 is? And divided by 27? 21.3, excuse me, 21.3 repeating. And then how would I write that on big ideas then? If I can't write 0.3 repeating, Lizzie? And 1/3, yeah, 0.3 repeating as a fraction is 1/3. I can write fractions on big ideas. I can't write repeating decimals. So if you have one like that, just convert it to a fraction. All right. And our last problem, the dimensions of this touch tank at an aquarium are doubled. What is the volume of the new tank? So if they're doubling the dimensions, that would be the side length, the length and the width, right? If they're doubling this touch tank, what are they going to multiply the side lengths by? Xander? Yeah, doubling means 2, okay? If they're doubling the side lengths by 2, what kind of effect is that going to have on the volume? Is it going to double the volume? No. Is it going to square the volume? No. Is it going to cube the volume? Yeah, it will be times 2 times 2 times 2. So actually, the volume of the new touch tank is going to be 8 times bigger, right? So if they're doubling all the side lengths, the effect that's going to have on the volume is it's going to make it 8 times larger. And if the current volume is 2,000, then Connor, what would 8 times that be? Be 16,000. Label your answer. Feet cubed. All right. That's it. That's section 8.4. Very similar to the one we did yesterday. So if you're wondering why I skipped and did 2.5 and then 2.7 and then went back to 2.6, because I wanted 2.6 and 8.4 to flow together just like this.